In this part, we're going to focus on simplifying radical expression. So let's take a look at our first example, square root of 12. So there's no perfect square number for 12. So that means that what we're going to do is we're going to break 12 into two factors, into two numbers. So the first thing is you need to find one where a perfect square number that can go into 12. So the only number that we can think of would be the 4. So it will be 4 times 3. So we just broke up 12 into two factors, the 4 and the 3. And usually we put the perfect square number first, and you see why. So when it's two factors, two numbers that are multiplying, you can split it into two separate square roots. So I'm going to have the square root of 4 times the square root of 3. Now, the reason we put the perfect square number first is because you can do the square root of the perfect square number, the 4. So the square root of 4 is just 2. And again, it's still multiplying to this, the square root of 3. So the square root of 3, there's no perfect square number for it, so it's going to stay as square root of 3. So, and again, it's multiplying. So since it's 2 times the square root of 3, then simply our final answer will just be 2 square root of 3. That will be your final answer. And to review, we broke square root of 12 into two factors, 4 and 3. 4 is a perfect square number, so that's why we use this pair. Broke it down into two square roots. Again, we put the square root, the perfect square number, in this case a 4, in the front is because when you simplify it, it's usually going to be in the front. Any number that's without the radical is always going to be in the front. Any numbers with the radical will always be in the back, just like this order right here and your final answer. So just make sure you remember that. Again, when you're simplifying, and if it's not a perfect square number, then you're simply just going to have to find two numbers that can go into the number in the problem, while one of these two, is a perfect square number. In this next example, we have the square root of 32. So, just like before, we're going to break it into two parts. Now, there's two possibilities. We can use 4, because 4 can go into 32 8 times. Or we can use 16. 16 can go into 32 2 times. So, since you have the possibility of a 4 or a 16, it's always a better chance with the higher perfect square number. So we're going to go with 16 times 2. And another reason why you want to use a perfect square number that's higher is it's going to be less work. Whereas if you use a lower number, you're going to basically keep breaking it down and doing more work. So if there's a higher perfect square number that you can use when you're breaking it down into factors, then use it and you end up doing less work versus using the lower perfect square number. Alright, so we're using 16 times 2. Since it's multiplying, we can split it into two square roots. So I'm going to have the square root of 16 times the square root of 2. So the first one, 16, is a perfect square number. So the square root of 16 is just 4. And again, since we're simplifying, we don't have to worry about doing plus and minus. We're not solving, we're just simply simplifying. So we're just going to assume that it's the principal root, so a positive 4. Now, the square root of 2, there is no perfect square number for 2, so it's going to stay as square root of 2. And just a reminder, it's multiplying, so 4 times square root of 2 would be simply 4 square root of 2. And that will be my final answer. So to review with this particular example, square root of 32, we had two options, the perfect square number 4 and the perfect square number 16. Now, it's better that you use a higher perfect square number because you do less work, meaning less breakup breakdown of the number and less doing the square root. Whereas 4, you can do 4, it's just that you're going to keep breaking it down into multiple factors and you're going to be doing multiple square roots of numbers. So it's going to be ended up doing more steps, whereas had you did with 16, you would do it into basically 3 or 4 steps. In this example, we have 7 square root of 20, meaning that 7 is multiplying to the square root of 20. So in this example, we have a number that's outside the square root. So that means that this number, the 7, will play a part into finding our final answer. So make sure you don't forget your 7. But since we need to simplify the square root of 20, we're going to do the same thing as before. So we're going to break it down 20 into 2 numbers. Perfect square number that can go into 20 is 4. So I'm going to break into 4 times 5 for the square root of 20. And then I'm just going to bring down the 7. Again, the 7 is still there, doesn't disappear. And just like before, we're going to break the square root of 4 times 5 into 2 square roots. So I'm, again, still going to have the 7 here. It's going to be the square root of 4 times the square root of 5. And again, I'm going to bring down the 7. But now, here the square root of 4 is 2. So now the 7 is going to multiply to the 2. Whereas the square root of 5, there is no perfect square number for 5. So it's going to stay the same. So square root of 5. Now, any numbers that you have that are without a square root, in this case the 7 and the 2, and it's multiplying, you're just going to multiply. So we're going to have 14 square root of 5. And that will be your final answer. Now, just like how I mentioned earlier, we had a number that's outside the radical, and it's going to play a part into finding your final solution. So what happened here is when we were simplifying the square root of 20, we got out 4 and 5, and 4 is a perfect square number, which became the 2. So when we did the square root of 2, that 2 is going to multiply to that 7, which is how we got 14. And square root of 5, there's no perfect square number, so it's going to stay as square root of 5. Therefore, our final answer is 14 square root of 5. In this example, we have negative 8 square root of 72. So now we have negative 8 outside the square root, so that means that it's going to be part of the work until it helps us find our final answer. So I'm going to have negative 8 outside. We're going to break up square root of 72 into 2 numbers. Now you can use 4, you can use 16. Another higher perfect square number for 72 is 36. So I'm going to break 72 into 36 times 2. Since the 36 and the 2 are multiplying, you can break it into the square root of 36 times the square root of 2. And again, we still have that square root of, the negative 8 outside. So we're going to bring it again, the negative 8, because it's going to help us find our final answer. The square root of 36 is a perfect square number, which is basically 6. Next, for the square root of 2, there is no perfect square number for it, so that means that it's going to stay the same, square root of 2. So now, we have the 6 that's outside the radical, and it's multiplying with the negative 8. So we're going to do negative 8 times 6, which is negative 48. And then it's multiplying to the square root of 2, so it's going to be negative 48 square root of 2. And that will be our final answer. So to review with this particular example, 72 had 3 possible perfect square number, which is the 4, the 16, and the 36. Now again, like I mentioned before, 36 is a higher perfect square number, meaning that if you use it, you do less steps. Whereas 16 and 4, you would do more steps. If you were to use 4, you would do multiple steps of breaking it down and doing multiple square roots. And then you would end up, like in here, we just do 6 times -8. You would have done multiple factors that multiply into -48. So the only difference between the three options, the 36, the 16, and the 4, is that you do more steps, but you should and always get the same answer if it was done correctly. Meaning doing the square root, meaning doing the breakdown of the numbers, and then multiplying the multiple factors into -48 square root of 2.